So Teacher Sam told me that you guys got to this point with this question on Monday, but you didn't get a chance to finish it off. So what I'm going to do is I'm going to pop it up here so you can take a screenshot to get the answer. And then if you could just have a look through it, if there's anything that you don't understand or you would like to ask a question on before we start dealing with today's questions, please just let me know. You're welcome to say it out loud. You can just unmute yourself and chat to me, or you can put it in the chat and I will explain whatever you need some explanation on. But this is where you guys ended on Monday. Hi to those who have just joined. Teacher Sam's writing is so neat. I'm so jealous, and I apologize now for the writing that is coming your way in the next hour. It is not this neat. I feel like she has a superpower. Okay, so feel free to take a screenshot. I'm going to give you a couple more minutes just to have a look at this. Let me know if you have any questions about what you're seeing. Quite a few of the questions we're going to deal with today are on the same path as these. So if there's something you don't understand, it's important that you ask. Okay. Cool. Just going to give yourself 5 past. For those of you who arrived late, hi, I'm Teacher Jen. I'm just looking after you for today, and I will be looking after you next week, Saturday, for your boot camp. All right, let's get going. Okay, I'm going to make this a little bit bigger, and we're just going to kind of deal with this question at a time. So let's highlight as we go with things that we need. In the figure, we've got L, which is -4 and 1. So we know we've got this vertex over here. We've got S, which is 4 and 5. And then we've got N, which is -2 and -3. Okay. They are all vertices of this triangle. And they're also telling us that SLN is at 90 degrees. Okay, so that's helpful for us. The first thing we have to do is calculate the length of SL. So that is this length over here. Who is feeling brave and can tell me the formula we are going to need to find this? You don't have to tell me everything about it, but anything you can tell me about how I can figure out the length of that line, I would love to know. You're welcome to unmute and say it out loud, or you can write it in the chat. If you don't want to write it to everyone, that's great. Can you see it? Excellent. Absolutely. We are wanting distance. So as soon as we see this word length, we want to think of the distance formula. Beautiful. Okay. Let's take this one step further. Does anyone know the distance formula? Or have you got a little formula sheet in front of you where you've got this written down? It's test our little brain buffs. I'll give you a helping hand. So I'll start with it like this. What's going to go inside that square root sign? Come on. I know you know. Okay, yeah, we're definitely going to look at the change of x's. Okay, so we're going to write in here the change of x's. So x2 minus x1, and then we're going to square that. And we're going to add, I'm going to need to make my square root sign a little bit longer. We're going to add our changes of y's, and we're going to square that. Okay, now, the most important thing with this is once you've written your formula, if you don't put in the correct values, it's going to hurt you for the rest of these questions. So analytical geometry, the nice thing about it is that it is scaffolded. So what you do in 3.1 will help you as you move on down. So they're trying to make harder questions easier by giving you ones beforehand. The horrible thing about that is that if you make a mistake, it can make your life a little bit difficult. They would do continued accuracy marks, so it's not like you wouldn't get any of the marks that follow, but you won't necessarily get really nice numbers. So the next important thing that we need to do is we need to make sure that we are substituting these numbers incorrectly. In order to do that, I actually suggest you take an extra step to ensure you get this right. So I would, at this point, I would label that x1, y1, x2, y2. Because then when I'm putting it into my formula, I cannot make a mistake. I know where my ones are, I know where my twos are. And all I need to do is put it into my formula. And that maybe will take you an extra 15 seconds. And I promise those 15 seconds will be worth your while later in this question. Okay, so I've helped you out a little bit on the board over here. I want you to fill in what you need to fill in. And then the question says that it would like its answer in third form. So we're going to make sure our answer has a square root sign when we give our answer. So we are all yours. Get those calculators out, pop in your numbers, substitute them in, and tell me what answer we get. I will not rush you. I'll give you time, but I want all of you to give this a go on your side. Your calculator is like your best friend in metric maths. Does everything you need. Hello, hello, my little new people. Okay, so at this point, what we're doing, if you just got here, is we are substituting in our values into our distance formula, and we are going to get an answer in third form. So that means our answer is going to have a root sign. So we're not going to give our answer as a decimal. Can you see there? I freaking love that answer. Glorious. Glorious. Okay. So the second step, what we're going to do is we're going to show our substitution. So we're going to say 4 minus -4. We're going to need to make sure that that's in brackets because we are subtracting a negative. If you go straight to saying 4 plus 4, totally fine. Okay. And we're going to square that. Plus y2 is 5 minus 1 squared. Now remember, you get a mark for showing that substitution. So it's important that you show that substitution into your formula. Okay, and so if we chuck that into our calculator exactly like that, we will get the answer for root 5. And because it's a length, we could say units, just to be nice and fancy, but that would be our final answer. Did anyone not get that answer and doesn't understand where they went wrong? Please let me know. Remember, you're welcome to send direct messages. The most common mistake here is not putting that negative sign in brackets, and so saying 4 minus 4 squared. So if you did that, that's a very normal mistake. Just remember not to do it in the future. I will leave this up here. So if you have questions, you're still welcome to ask. Also now, guys, can you see Leah has helped you out? She gave the first answer. So now the rest of you are going to have to start stepping up and giving me answers because I'm going to have to start picking on you otherwise. Will you be penalized if you don't specify units? No, I don't think you would be. It was like a pet peeve that my math teacher had when I was in high school. So now I just automatically do it, but I definitely don't think you would be penalized. Okay. All right, so no worries. 3.2, calculate the gradient. Ooh, now I'm getting into spicy questions. The gradient of Sn. Okay, so let's have a look at Sn. This is our line Sn over here. What is the formula to work out the gradient of a line? What is the formula to work out the gradient of a line? Come on, my little brain buffs. I know you know. Let's just rip off the Band-Aid and give it a try. Ooh, okay. Beautiful. Absolutely beautiful. So we have the change of y over the change of x. Love it. Absolutely. Okay. So if we're looking for our gradient, we use the m for gradient. It would be the change of y. So y2 minus y1 over x2 minus x1. Okay, cool. So let's have a look now. I'm just going to get rid of our previous ones that we used so that we don't let them confuse us. And let's have a look. We're now looking for this pink line, okay? So I'm going to make this x1 and y1, and doesn't matter, you could make it x2 and y2. It doesn't matter as long as the ones are together. And let's make this x2 and y2. Okay, so m is going to be equal to y2. So we know that that's -3 minus y1, which is 5, over x2. So that's -2 minus x1, which is 4. All right. And chuck that into your calculators and tell me what glorious answer you should get. You should get a nice fraction. Yes. Good. Nice. I think you guys think I'm all talking to myself, but I'm getting direct messages, I promise. Okay. So 4/3 is absolutely right. So what we would have over here is this. I'm just going to put it in brackets so that you can see. It would be -8 over -6. And so if I simplified that, the negative and the negative would be a positive, and the 8 and the 6 would become 4/3. But you don't need to worry about that. Your calculator does all the hard work for you. So we can just say m is equal to 4/3. Again, if you want to be super fancy or you want to make sure you know what you're talking about as you're working through this, you can say the m of Sn is equal to 4/3. So that's just a way of you reminding yourself what you've worked out so that later on in the questions, if they need something, you've been very clear about what that gradient is. Because remember, when you're in an exam situation, it's very easy to get frazzled and stressed and get yourself into like a little anxiety loop and you forget what you've done. So the more clear you are with yourself, the more it helps you later on. Okay, cool. Let's have a look at our next one. 3.3, calculate the size of theta, the angle of inclination of Sn. Okay, so our angle of inclination is happening over here. This is our theta. So they're wanting to know what that angle is over there. Remember what I said earlier, analytical geometry questions are built in a way to help you. So whatever happened before is generally there to help you afterwards. Who thinks they can tell me what we would use, what formula we would use to find theta here, knowing that we've just found the gradient of Sn? What formula could we use? I'll give you a hint. It's going to involve some trig. Angle of inclination is absolutely what we're looking for. Tan gradient. Yes. Nice. Okay. So when we're looking for this angle of inclination, we can say that tan theta is equal to the gradient of that line. So in this case, it would be the gradient of Sn. Okay, so tan theta is equal to the gradient of Sn. We don't know what theta is, so we're going to say tan theta is equal to, but we do know the gradient of Sn because we've just worked it out. So we can say, cool, well, that's equal to 4/3. What do I do now? If I'm trying to find theta, and I've got tan on the one side of the equal sign, and I've got my answer on the other side of the equal sign, what do I do on my calculator to help me out in this moment? We are absolutely isolating theta. How do we isolate theta in this situation? What do we do on our calculator? Shift tan. Yes, guys, glorious. Yes, absolutely. Okay, when we've got tan just chilling right here next to theta, we need to do shift tan. Okay, so shift is our friend on our calculator. So grab your calculators, you're going to say shift tan, and in brackets, you're going to put your fraction, and I want you to tell me what you get and round it off to 2 decimal places. Glorious, Leila. Yes. Okay, so therefore, tan is equal to 53,13 degrees. Nice. Lovely. Okay. Question 3.4 is a little bit lower down. So if you would like, this might be a good time to take a screenshot of these first 3 questions. And then we will try with 3.4. Please remember, if I'm going too fast at any point, please tell me. And if there's something you don't understand, just ask. I don't mind going over something again. You just need to let me know. Okay, let's have a look at 3.4. Sorry, my dog. Okay, 3.4, determine the equation of the line which passes through L and is parallel to Sn. Okay, so it's told us some important things here. First of all, they've actually been quite nice. They've told us that they're wanting it in the form y equals mx plus c. So we know which equation we're working with, okay? We know that it passes through L. So let's have a look at our picture over here. Just zoom out a little bit so we can squeeze that in. Okay, so we know that it's going to pass through this dude over here. So L is -4 and 1. That's what L is. And then they're telling us that it is parallel to Sn. What important piece of information are they telling us by saying that it is parallel to Sn? What is a very important thing that we need to take from that? Yes, absolutely. It has the same gradient as Sn. Okay, so when we have parallel lines, they have the same gradient. Let's just write that out. Parallel lines, same gradient. I know you guys are going to be so excited for Teacher Sam to be back with her neat writing. I'm sorry. Okay, parallel lines equal same gradient. So if we know it's parallel to Sn, we know that our gradient is going to be 4/3 because we've already calculated that. Again, remember, in analytical geometry, what we've done before helps us later. Okay, cool. So we actually don't need our picture now because we have all the information we need here. So Let's zoom in a little bit. Okay, suggestions. Where can I go from here? You don't need to tell me the whole way forward. I just need to know we're in a test situation. We've got what we have in front of us now. What do we start with? And even if you have no idea what to do, just suggest what you think you would do if you were in the situation. Because remember, we never want to leave blank spaces. Substitution for M. Great. Okay. My general go-to is, especially when you're in a panic, you write the formula. That's what I always start with, because if we have the formula, we don't have a blank space anymore. And psychologically, that can help us. Because when there's this blank space, it feels so daunting. You don't know where to start. You don't know what's going on. But as soon as we've written something, it does help us a little bit. Okay. Great suggestion. Substitute M. So we're going to substitute our gradient in over here. So we're going to say, cool, y is equal to 4 over 3x plus c. Great. Where do I go to from here? We've used one piece of information that they've given us. We haven't used the other piece of information yet. So how do we use the second? Yes, good. We substitute those coordinates in. Okay, so remember this is x and this is y. So we're just going to sub in those coordinates. So 1 is equal to 4 over 3 times negative 4 plus c. Now, there's lots of different ways you can go about this. I'll show you 2 different ways. It depends on how your brain works when it comes to equations. The first way is we're just going to work it out with fractions. Okay, so we're going to say 1 is equal to negative 16 over 3 plus c, which means 1 plus 16 over 3 is equal to c. And let's quickly see what that would give us. 1 plus 16 over 3 gives us 19 over 3. I think I got a different number to that earlier. Let me just make sure I haven't made a mistake. I just want to make sure that I've written L's coordinates down correctly. Negative 4 and 1. 4 and 3. Yes. Negative 16 over 3. I'm happy with that. Y is 1. Okay. Well, then I agree. I agree with myself. Okay. 1 plus 16 over 3. And we get 19 over 3. If you're getting a different answer, let me know. Let me know if I have gone haywire somewhere. Okay, so that's if we did the method just working with our fractions. Perfectly okay way to do it. The other way to do it is to get that denominator out in front of everything. So let's work from the step over here. So where we have this 1 is equal to negative 16 over 3 plus c. If we wanted to not have that denominator anymore, we'd need to make sure all of them have the same denominator. So we'd need to multiply that by 3, and we need to multiply that by 3. So we would have 3 is equal to negative 16 plus 3c. And then we're going to keep on going. So we're going to say 3 plus 16 is equal to 3c, which means 19 is equal to 3c, which means 19 over 3 is c. Both methods are perfectly fine. It just depends on how you work with equations. You must do it a way you are comfortable with. Anyone have any questions about this? I know that this seems a little bit confusing. So if you have questions, let me know. No, your teachers won't take off marks for doing either one of the ways. Whichever way you do it is fine, as long as it's a way that you're comfortable with. We actually haven't fully answered this question yet. Can someone tell me what we have to do to get our last mark? because we would have gotten most of our marks at this point, but we haven't gotten our final mark for this question. Yes, glorious. Thank you, Layla. It said very clearly that it wants us to write our answer in the form of y equals mx plus c, which means we need to do that. Okay, so we're going to end off our answer, making sure we write it exactly as they want, which is y is equal to our gradient, which is 4 over 3x plus 19 over 3. And that is our final mark. Always remember to write that. That is a very, very irritating place to lose a mark. When you go over your exams or your tests, if you see that you've done that, you will be very frustrated with yourself. Cool. If you would like to take a screenshot, please feel free. And then we're going to jump into question 3.5. Try and get that all in. Okay, our last question is one of the ones which I find the most annoying, to be honest. But the good news is you get lots of marks for it. So let's focus on that. The question here says, calculate the area of triangle LSN. So we're looking for this area over here. We know it is a right angle triangle, which is very helpful to us. What is the formula we are going to use when it comes to working out our area of a triangle? What formula do we use? Yes, nice. Glorious. Okay, let me get rid of all this writing so that we can see properly what we're doing. Okay, absolutely. So when we're working out the area of a triangle, we want to say the area of a triangle is equal to half of our base times our perpendicular height. Okay, so if we look at our picture, we've got our two lines that are perpendicular to each other. It doesn't matter which one's your base and which one's your height, as long as it's the two lines that are perpendicular. Okay, we already know some things. So we know that SL is 4 root 5, because we worked that out in question 3.1. So now we need to work out LN. Everything you need is on the board. There is nothing you don't have that's on the board. I would really like you guys to work this question out yourselves. I've given you your helping hands. I've scaffolded it a little bit. You're going to need to find LN, and then you're going to be able to find your area. So I want you to work this one out and tell me your area. Put your answer in your chat once you have one. Show me with a little emoji when you're done, so I know how many people are done and I don't rush you. And then I'll go through this, and then we can jump onto our next set of questions. You're doing really well, guys. Just keep going. And remember, if you're feeling lost while you're working on it, ask away. I'm happy to give you some helping hands. But I think everything you need is on the screen. Okay, so Pythagoras, you could technically use Pythagoras, but Pythagoras we use Pythagoras to find the lengths of sides. We don't have the length of SN, so you would have to find the length then anyway of one of the extra sides before working out the area. So my answer is yes and no. You could use Pythagoras to get you to where you need to go. But yeah, it would probably be using too much time. Very good note, though, that you saw that there was a right angle and you thought Pythagoras. That's very good. Yeah, I'm going to give you guys 2 more minutes to work on this one. Yay! Nice. Woohoo! Thanks for letting me know, guys. It's very helpful. Okay. Okay, so let's start by finding the distance of Ln. Okay, so Ln, that in for me. Okay, Ln is equal to the square root of. If I'm looking at this, I'm going to make this one x1, y1. I'm going to make this x2, y2. All right. So we're going to say x2, so that's -2 minus x1 minus -4 all squared plus y2, which is -3 minus 1 all squared. Okay. And if we pop that into our calculator, we should get, if I remember correctly, I think it's 2√5. Hopefully I am remembering this right. If I'm not, let me know. If you've got a very different answer, let me know. Okay, so now we have Ln, which means we have our base and we have our height. So we can say, cool, that means our area is going to be equal to half of our base. So I'm going to use 4√5 times our height, which is 2√5. We're going to put that into the calculator exactly like that. So exactly like you're seeing on the screen. So we're going to have a half, open bracket, 4√5, close bracket, open our next bracket, 2√5. And we get the glorious answer of 20 units squared. And it would be squared because it is an area. Do we have any brain buffs who got this right? If you are looking at it yourselves, I want you to give yourselves a mark for getting the 2√5. I want you to give yourselves a mark for showing your substitution and then a final mark for your answer. Nice job. I'm seeing some thumbs up. Like it. Nice work. Okay, please feel free to take a screenshot and then we are going to jump into another set of questions. Okay. All right, let's have a look at this next dude. Whew, this one looks exciting. We'll see how far we get. Okay, in the diagram, we've been given points A, B, C, and E. Okay, we've been told we have a triangle ABC. Nice. Line BC is produced to H. Cool, so that all that means is that this is one line. Woo! Oh my goodness! That is one line. Okay, so as soon as it says it's produced to H, it just means that BC is carrying on to H. It is a one line. That's all that means. Okay, and it cuts the x-axis at E, which is 12 and 0. Cool. AB and AC, so let's have a look at those. So that's AB and AC intersect the x-axis at F and G. Cool. Okay. So all that that's telling us is that this point over here and this point over here are on the x-axis. Nice. The angle of inclination of line AB is 81,87 degrees. So that's telling us this angle of inclination over here. Cool. Let's have a look at our questions. Calculate the gradient of BE. Okay. What am I going to do? Because I'm looking at this blue line here. And if I look at B, I've got two unknowns. And E, I've got 12 and 0. So that's cool. E, I'm happy with. What am I going to do to find this gradient? Because they want the gradient of BE, but I don't know what B is. So the angle of inclination would be a tricky one here because we don't have quite enough information. Ah, glorious. Yes. Use point C. Okay. They told us in the description that C is on that same line. So the gradient of BE is the same as the gradient of CE. Let's just write that in here. So the gradient of BE is the same as the gradient of CE because it's on the same line. Okay, so we can just use C and E for our gradient over here. So let's make this x1 and y1 and x2 and y2. And can you please pop that into your gradient formula, which I'll quickly write up here. And let me know what you get for your gradient. Don't forget your brackets when you're subtracting a negative. What is our final gradient answer going to be? Pop it into your calculator. 1/4. I love it. Absolutely. Glorious. Okay, so we have our gradient. Cool. It's a good start. Next thing they're wanting from us is they want the gradient of AB. Okay, so now that's this line over here. And again, we don't know what B is. So we're going to have to think of a different way of working this out because we don't have B. Someone did have a really good suggestion earlier on how we could work this out, which wouldn't have helped us for BE, but it will definitely help us for AB. Yes, the angle of inclination. Good. Okay. So remember, the angle of inclination and our gradient are hand in hand with each other. Okay, let's just write that over here. Tan theta, so the tan of your angle of inclination, is always equal to the gradient of that line. So in this case, we can say tan of 81,87 is equal to the gradient of AB. Okay, pop it into your calculators. Don't fall for the trick here. There's a little hole that lots of people fall into, a little trap, where they think that they must still use shift, but we don't need to use shift because that angle is right next to tan. So we can chuck it into our calculator exactly like that and tell me what our gradient is going to be. You can round it off to 2 decimal places. You can actually round it off to a whole number. Yes, glorious. Okay, so if you pop this into your calculator, you should get 7,00 something. So we can actually just say that our gradient is equal to 7. Done. Easy peasy. Okay, 3.2. Determine the equation of BE. Okay, so that's our blue line, in the form of y equals mx plus c. Okay, so we know some things already. What do we know already about that blue line? We know something important about it, because we worked it out earlier. Good, the gradient, excellent. Okay, so we know that our m is equal to 1/4. Okay, so let's start this out. Y equals mx plus c. Cool. We know our gradient is 1/4, so we can sub that in. Now I need to find c. How am I going to find c? Good. You can sub in any of those points. You could sub in C or you could sub in E. Perfect. Okay. So I'm going to sub in E. So I'm going to sub in 12 and 0. Okay. So my Y is 0. I'm going to say 1/4 times 12 plus C. So 0 is equal to 3 plus C, which means C is equal to -3. Okay, again, we haven't finished it because we haven't given it our final answer. So we're going to say y is equal to 1/4 x minus 3. Cool. Remember, if you're not understanding something, please ask. I'm here to help you. If you want to take a screenshot of these 3 questions, it might be a good time because the one we're going to go on to next, we're going to have to scroll down. So we'll miss some things. So this would be a good time to take a screenshot. Oh, this is a lovely question. Okay, calculate the coordinates of B where K is less than 0. So all this little part over here, let's just highlight it. This little part over here, it looks confusing, but all it's telling us is that B is the K is a negative number. Okay, so we know that they are the same as each other because they're both K, and we know that they are both negative. That's all that's saying. All right. Who has a suggestion on how we can go about figuring out what those points are? Any suggestions are welcome right now. There are no bad answers. Well, I mean, there are answers which won't help us, but I look forward to your suggestions. subpoint E. Okay, let's have a look at that. Subpoint E. We can definitely use the fact that we know E. What if you just worked out in 3.2? Use the answer in 3.2 and make it an inequality. Glorious. We don't even need to make it an inequality, to be honest. You can, but I'll show you. Just to keep your life even easier. You've just worked out the equation of BE. You worked that out in 3.2. Okay, so I'm just going to write here so that we can see everything. We know that the equation for BE is y is equal to a quarter x minus 3. Okay. We also know that that is an x value and that is a y value. So why don't we sub it in? Because we know that they're the same as each other. So we can actually just sub in b. I'm just going to write that here. So I'm going to sub in b, which is k and k. All right. K is equal to a quarter k minus 3. That's not so bad. Let's get rid of our fractions. So 4k is equal to 1k minus 3. I'm going to move my k's over. So 4k minus 1k equals negative 3, which means 3k is equal to negative 3, and k is equal to negative 1. Do we like this? Do we not like this? Oh, we shook it? This is a good answer? I don't know. I can't read the room. Isn't it cool though? Sometimes maths can be cool. Sometimes it's like a little bit like magic maths. So the reason I said you don't have to make it an inequality is because often when students see stuff like this, it's like erasing the question. As soon as you see something is less than or greater than, or nature of roots, anything like that, generally we tend to panic and we think, oh, I have no idea how to start this. So if we can avoid doing it as an equality, if we can do it just as an equation, which is something we're more comfortable with because we've been doing them for longer, then that's great. Okay, we're actually not going to do this question 3.4 because I want us to give another question a go. I'm just going to zoom out a little bit so that you can get all of this in. Just will be quite small. And then we can try one more baby question before I have to leave you guys for the other matrix. Okay. We'll probably only get through the first little bit of this, but that's okay. So in our diagram, let's have a look. We've got diagram. They've given us coordinates. We've got R, S, T, and C. They've told us it's a trapezium. We know it's a trapezium because this line here is parallel to this line over here, which is going to be useful to us. Remember, they don't ever tell you things that aren't useful. RS and PR cut the y-axis at D, okay, and C, cool. We also have our value for C, great. PT and RS cut the x-axis at E and F respectively, cool, and PEF is theta, great. First step, write down the equation of PR. Okay, so let's have a look. PR is this line over here. There is some very important information in the coordinates that you can see for C and R. So the coordinates of C are 0 and 5, and the coordinates of R are 3 and 5. So there's something very important that you need to see there in order to write this equation. Give it a go. That should help. Remember, it's not going to be like a long saga where you're going to have to find a whole bunch of things, because it's just your first question of this, which means it's generally like a nice, easy, quick answer. So which values are the same as each other, and what does that mean about the line? Yeah, your y values are the same as each other. Okay, so your y values are both 5. Because your y values are the same as each other, it means that this line over here is a straight line. Okay, and it's a straight line that is parallel to the x-axis. So anywhere, any point along there, I don't know what my x value would be, but I know my y value would be 5. I don't know what my x value would be, but I know my y value would be 5. Okay, because our y value doesn't change as we move along that line, the equation of that line is just going to be y is equal to 5. Because x can be any number, doesn't matter what x is, y is always going to equal 5. And that's our whole equation. Does that make sense? And then if I had numbers like this, if I had lines where this value was -7 and 4, and let's say this was -7 and 0, and this was -7 and -6. In that case, all of my x values are the same. And so this line is parallel to my y-axis, which means it would be x is equal to -7. That would be its whole equation. Okay, my lovely little moon pies, I'm going to have to leave you to go to our other matrix. I hope you have a really good evening. Thank you for being a lovely class. Thank you for answering the questions and for being